navigating transport. On our team, we have Sean Buckley, Vertepper and Into Dragos. My name is Jeffrey Limbacher. In the back, we have David Wu and Young Kim, and we have Narsane on our team as well, who's manning our display. Oh, and we have our customer, Dr. New Ho, with the Systems Engineering Research Lab, who's a mechanical engineering professor here at CSUN. All right, so here's our agenda for today. First, we're going to start with our motivation and our vision statement, some goals and assumptions we made along the way. We're going to go over our development process, and we'd like to end with conclusions, acknowledgments, and references. So for motivation, there's growing interest in drones. There's a ton of projects out there that relate to UAVs. Ours do it well as well. But you always hear about hobbyists who are flying drones and getting in trouble for flying them too high. But besides entertainment, there's many different practical applications for drones. There's taking pictures, agriculture, search and rescue, and of particular importance to us is cargo delivery. We've had some major players such as Google and Amazon express interest in using drones as a delivery service. And in addition, we have our customer, Dr. New Ho. He wants a large-scale unmanned aircraft management system and test bed so that he can conduct research with it. However, there's still many challenges that need to be addressed. The first challenge is safety. We need these vehicles to avoid people if they're going to be performing deliveries. In addition, we need to avoid obstacles. You don't want the drone to crash into the side of your house and cause damage. And there's the human element as well as managing them. Right here we have the United States National Airspace. Each yellow dot represents a commercial airline flight. If one of these has a problem, someone on the ground has to be dedicated to help fixing that problem. And that means that they need the correct information to address that problem as well. We also have the operator automation interaction. What role is the operator going to play? What role is automation going to play? And how are they going to play together? So in the near future, these vehicles will be able to do fully autonomous flight. However, when they run into problems, just like the airlines, we need a human on the ground who's going to be able to intervene and help them go through the problem. Current control systems, such as ground control stations, are not a good solution and don't scale up with the number of UAVs because they typically have poor operator-to-vehicle ratios, typically 1-to-1. So NEST aims to be a large-scale UAS management system that provides automation and tools for the operators to be able to manage a large fleet of vehicles effectively.
Hi everyone, I'm Jayos, and I'm going to be talking about our project goals. Our biggest goal was to develop an air operations control center for these UAVs, in which a team of 1 to 10 operators could control somewhere around 500 to 1,000 UAVs. And we also wanted to provide these operators access to certain UAV metrics, such as battery life, as well as implementing navigational commands, so an operator is able to modify the flight path of the UAV. We also wanted to design an experiment in order to test everything, and we did that by introducing outsiders to our project, which acted as users. And our final goal was constructing a working prototype by leveraging the knowledge that we've learned from our previous classes.
Hello everyone, I'm Sean. So because of our project's complexity, we needed to do some research for our requirements. For inspiration, we looked at systems that faced similarly complex problems, such as air operation centers at airports, and dispatch systems such as those used by UPS trucks and taxis. In addition, to help focus our research, we focused on domains based on their strength. We looked at NASA and the military for how they display multiple facets of information across multiple displays. And we looked at gaming for how to command and control multiple units at once, and to display large amounts of information given a small screen real estate. Additionally, we met with our customer, Dr. Ho, to help refine our requirements. So we had to make some assumptions for our requirements. Currently, the FAA does not allow commercial flights of UAVs, and it certainly does not allow UAV flights over populated areas. Part of this is because UAVs are not integrated into the national airspace system. We have to assume that these sort of restrictions do not apply for our project to be feasible. In addition, we need to assume a certain level of automation for the UAVs. They need to have a certain level of object avoidance so they don't run into birds on their own, or run into the ground, or in case there's wind pushing them off course, they need to be able to get back on the track on their own.
Hi, I'm Vertep, and I'll be talking about the development process and technologies we use. So in terms of our project timeline, we split up our work into 3 major milestones. In the first major milestone, we gathered requirements and chose frameworks and technologies. We then designed mockups for our UI. In the second major milestone, we implemented a simulation that would power our UAVs so the operators can handle them. You can see here that we had some spillage due to us switching our mapping solution technology. In our third major milestone, we started implementing new features for the experiment that we formulated, which Drug was mentioned earlier. We then did some testing and bug fixing, which also caused some spillage. In the end, we had the experiment. In terms of our technology choices, we wanted to create a web application because it allows us to leverage the web technologies, including handling the states of multiple users simultaneously. So for this, we use Microsoft's ASP.NET MVC. This is because it's well supported, has a strong community, and it provides extensive libraries, including SignalR. SignalR is a library that allows real-time communication between the backend and the front end, and this is bidirectionally and simultaneously. We also use HTML, JavaScript, and CSS because these are very common web technology frameworks or tools. We use AngularJS, which is a front-end JavaScript UI framework. This allowed us to create highly interactive front-end code. We also use Google Maps as our mapping technology solution because that was very well documented. In terms of our team member roles and responsibilities, we split up our work into two major components, the front end and the back end. For the front end, we had the Google Map view being the main component. For the back end, we had the REST API being the main component. For our development process, we used the Agile. For our Agile methodology, we used Scrum. This consisted of 1 week sprints. We would gather requirements from Dr. Ho, and then we would turn those into tasks. We would then populate the backlog with those tasks. We would then assign those tasks and pull them from the backlog. We also use continuous integration. This was to ensure project stability. We use Travis CI, which is an external application that we use to automate our builds. We would also meet with industry professionals to talk about our requirements and our assumptions as well. We also occasionally did team bonding to ensure that our team members were engaged. For sprint workflow, we would start off by looking at our goal overview, and then from the goal overview, we would create tangible tasks. And by tangible tasks, I mean small enough tasks that you can do within the sprint scope. And then we would assign those sprint tasks and pull them from the backlog. We would then go on to meet midweek and do code reviews as well as assistance and learning. In the assistance and learning, we would watch videos and learn new technology. At the end of the sprint, we would then critique each other on what happened throughout the sprint. Also, every day throughout the sprint, we would do daily stand-ups. This consisted of talking about what happened the day before, what we're planning on doing that day, as well as any blockers inside a project. And then the cycle repeats itself. For our project management tools, we use Slack and Skype for communication. Slack is a real-time chat application. We use Skype for our meetings. We use Google Drive for content sharing, which is part of our project asset library. For source control, we use Atlassian SourceTree, which is a graphical user interface that we used for Git, and we hooked that into GitHub, which was also part of our project asset library. For project management, we use Jira. For mockups, we use Balsamiq. This is an example of a burn-down chart. So as you complete tasks, the lines will go down. This gray line is our desired progress, but in reality, the red line is what occurs.
So as Veritab mentioned, we created mockups to help drive the design of our UI. This is what we called our overview, where you will be able to see all the UAVs that are currently in the area as displayed on the map. Here you have a UAV following a predetermined flight path to a destination with some basic information such as its ID number, its mission phase, and its battery health. Additionally, you can see that there are some commands that the operator would be able to give a UAV in the event of emergency or in case some other interaction is involved. Whereas that was an overall view, we also have a detailed view where it displays a list format of all the UAVs that are currently in the air. And if you select a UAV from that list, you get some very specific detail about that UAV.
All right, we're going to do a short demo. Don't blink because it's going to go by fast, but I do encourage everyone here to stop by our table so they can see our project in its entirety. And before we start, Before we start, I just want to make a quick note that I'm going to be referring to these vehicles by their call sign. And in the beginning here, we can see that there's a problem, and I'm going to select all of them. There's a low battery one by Hop28, and I'm going to focus solely on him. I can see that it's popped up in the event log as well, so I'm going to filter everything else by the UAVs that are assigned to me. I'm going to acknowledge that low battery warning and check his battery estimate. I can see he can barely make it, so I'm just going to send him back to base. I can see Mark 89 is drifting into the Van Nuys Airport airspace, so I'm going to put a restricted area over there. and he's going to tell me that his delivery is in that area, and I'm going to see that event, I'm going to acknowledge it. I'm going to have to turn it back to base as well, since we need to reconfirm that delivery. Abby 66 over here seems to be drifting too close to a restricted area, so I'm just going to reroute her. And Mark 63, he seems to be doing fine, but I'm just going to monitor him and follow this flight path to make sure that everything's clear. And now in terms of our experiment, we had a total of 3 operators, and they were brought in from the outside, and we were split up into 2 different teams, an admin team and a users team. And we had 2 different trials, one with 50 UAVs and another with 100 UAVs. And at the end of it all, we presented these participants with the NASA Task Load Index survey, which assessed overall workload on certain metrics such as mental demand, physical demand, and effort. And in terms of our results, we found that our most useful displays or pages were the map page and our detail page. The participants did eventually become overwhelmed, and that was mainly due because the admin team was bombarding them with events that might not otherwise occur in a real life situation, in order to kind of just stress test the system. And now Jeff is going to finish off with our conclusion.
So we learned, we accomplished many things along the way of the project. As Drago's demonstrated, he was able to take command and control of the vehicle. He gave new waypoints. He sent some of the vehicles back to base. We have multiple displays for providing information to the operators, as we showed in those mock-ups. Drago's demonstrated the map view in the system, but we also have a display for vehicle-specific information. Both of these show the operational status of the vehicles. All the displays in our system also support showing large amounts of UAVs. In the map, you can select all of them. In the detail view, you can search, filter, sort, and select the one that you need to address. Events bring operator attention to issues. So as you saw on the bottom right, we got demo. Drago's had a warning about a low battery. He also had a event log on the top right. And we also have a system for UAV assignment based on problems that the UAVs are having, so that we know that the operators are addressing these problems. Some future work that can come out of this project. Looking into the operator's influence in safety, especially when you bring automation into the mix. A reactive automation would address problems for the operator. Predictive systems would try to predict problems happening. The operator can play this role as well. Also, what information to present to the operator. We had a battery indicator that Dragos used to make sure that the vehicle can make it to its destination. So that brings us to my point, the last point, that information is context sensitive. What information do you bring up at what time? Some things we learned as a team as we were developing this project. Right when we wanted to code, we started coding. We didn't spend much time thinking about things, and it kind of hurt us later on. Communication is key. In our first semester, we didn't communicate as much. We didn't really utilize the tools that we had. In the second semester, we communicated much more, and as a result, our team performed much better. And on to the next point, it's important to adapt the process to the team. So we changed the sprint length from 2 weeks to 1 week as a result of a group decision of our team. And we also created subgroups where we would meet at different points in the week in these subgroups. And we would share information with each other regarding how different components of our system work. That way, everyone could work on every part of our system. Here we felt like this was symbolic of our team progress. Here we have our first semester burn down chart. We have these terrible ups and downs, and where we started versus where we ended is not much better. And our estimation was all the way at the bottom because we messed up our burn down chart. In the second semester, though, you see we have the line. We are pretty close to it. We got most of our tasks done. Acknowledgements that we'd like to make before we conclude. Dr. Newt Ho, Dr. Walter Johnson from NASA Ames Research Center, and Cody Evans, an airlines dispatch expert, who helped us along the way. And thank you for listening, and we'll take questions now.
How did you go up on the burn down chart? Was that a requirements thing or something?
So
I think it had an issue in the middle of the sprint. It increases the time estimate, which is what that red line is.
Yeah.
So when we have more time,
or reopening a task as well. Yeah.
Interesting.
I was going to ask when you went through a 1 week sprint, but you answered that. So you said you were doing agile, you were doing daily stand-ups, and yet you still had communication problems. So were you not doing your daily stand-ups in the beginning, or how did that play out?
In the first semester, we met twice a week for class, and we just used those meetings to utilize the time. In the second semester, we're like, no, we need to post in Slack now. Like everyone's gonna report out, and it helped a lot. You know, so we'd ask like, hey, what's going on? So people wouldn't do anything because they have other classes and other things going on in their life. But that was fine. You know, it helped us keep tabs on everyone so that towards the end of the week, it's like, hey, what's happening? Like, do you need help?
How was the participation on a daily basis?
It was very good throughout the second semester.
Yeah.
We kept it up pretty well for a long time.
How did you guys choose who did what?
Part of it was what we started out with, what we wanted to work on and what we felt comfortable with, but as the project progressed, we realized, as Jeff said, that we needed to spread out our specialization so that people could work on multiple things. So from there, we kind of expanded. We decided, oh, maybe it's time I start working on something else. Maybe I expand my value to the team. And so I'll try to take on these other tasks. And maybe they'll take a little bit longer because I'm not used to it, but then afterwards, I'll be able to use my time in the future working on similar tasks.
And building on top of what Sean said, the assistance learning really helped a lot too. So it allowed us to not just focus on one thing, but rather learn a lot of new things on our technology stack.
I think the key to that was just creating the subgroups and the daily stand-ups on Slack, especially that we implemented the second semester. I mean, we were way more communicative, and if anyone had an issue, it could be solved near immediately with the daily stand-up itself and dealing with the blockages.
Any discussions? Good job answering during the presentation.
Thank you.
No more questions? Any other questions?
Anyone else?
Did you have any coding standards? How did you meld all your code together?
We use GitHub as our source control for that, and we would push daily builds. Sometimes we'll branch off if we have a different section to work on. So like say maybe somebody wanted to work on maps, but they don't want to mess up somebody else's work on their map, so they would create a new branch, and then they would merge the branches at the end. So.
And Travis also really helped. We used an external application that Berta mentioned earlier. We could see right away it was connected to Slack, so if any build failed, we would see right away a new post like, hey guys, your build failed recently, and whose build it was, and we could just go back right away and see what the cause was.
Did it build on every check-in or on a schedule?
On every single commit.
Thank you.
Okay, thank you.